I have shared with you of how we can actually use the appendices to get the information such as the specific enthalpy at different temperature and what type of steam, for example, involved, because this is related to steam table. So the next thing that we wanted to do is actually to write the energy balance and solve it for the desired quantity. So we know that the previous problem in part A, it is actually we are talking about open system. So when it is an open system, we know that the equation that straight away that we want to use is delta H plus delta EK plus delta EP equals to Q minus W. And you remember that there is a dot up here which is actually represented the flow rate because it involved the rate, right? So we wanted to know here in this term, it is actually how much heat is being provided per second in order for us to heat up from that 100 degrees Celsius to 400 degrees Celsius, from saturated steam to become superheated steam. In this case, there is no work done by the system because you assume that this is continuous. You don't put any kind of shaft or agitator whatsoever. And we assume that work done by the system is actually equals to work done to the system, as if in term of the workflow. So there is no work, there is no potential energy involved, there is no change of kinetic energy involved. So everything is equals to zero. So end up, you just only have Q is equals to delta H. And another way for us, because this is actually, you know that this is in term of the unit is given as kilojoule per kilogram. Okay, this is also kilojoule per kilogram. And the unit given here is kilogram per second. So because this is just a specific enthalpy, so what you have to do is actually you need to cancel out, minus these two together. In the previous information, you got 32788 minus 26, if I'm not mistaken, 2676. All right. And then the unit here, and then the amount M that you provided here is actually 100 kilogram per second. Okay. So you can cancel out the kilogram. So what you have is only kilojoule per second. So this is where actually you can calculate your Q as what is being shown in this equation. So here you have the H outlet and minus H inlet, which is 3278.2 minus 2676.1. Both are actually kilojoule per kilogram because this is a specific enthalpy, okay, which means that this is the enthalpy per kilogram. And then you multiply with the flow rate, which is 100 kilogram per second, and you multiply with the different unit. You want to change from kilojoule to joule, okay. So finally, when you calculate here, then you'll get 6.02 times 10 to the power of 7 joule per second. So what does this number means? It means that, okay, again, this is determined about Q. It means that this is the amount of heat, okay, the amount of heat, or because this is joule per second, this is actually equivalent to power, okay. So what is power? You can also convert into the unit of watt, okay, W-A-T-T. So when you have this, it shows that you need this amount of power in order for you to convert 100 kilogram, 100 kilogram per second of steam at 100 degrees Celsius, which is saturated, into superheated steam at 400 degrees Celsius. Okay, okay, into the superheated steam at 400 degrees Celsius. So this is the amount needed to heat up the system so that from 100 degree it becomes 400 degrees Celsius. So that is actually the simple energy balance calculation that we could do.